Hi, this is Synthchaser from synthchaser.com. Today we're going to be repairing Jeff's ARP Omni 2. It has a few problems. So the violin voice isn't working at all, but the viola is. The cello is not working, but the bass is. On the synthesizer section, the same equivalents to the strings aren't working. So the 4-foot strings aren't working, but the 8-foot strings are. The 8-foot bass isn't working, but the 16-foot bass is. Some other issues as this 8-foot synthesizer button is kind of intermittent. See, now it's not turning it off, and there it turned it off. So we need to look to see if that's an issue with the switch or with the circuitry behind the switch. And then another issue is the release is not being controlled by the release slider. So I have release set to very fast, so when I push the keys down and I let go, the sound should stop. And it helps if I put on the voice that's working. So it's the release is too long, and if I change the slider, it has no effect. It has no effect on the release time. So that's another issue that we're going to be troubleshooting. So let's open this up and figure this stuff out. So for the 4-foot strings not working, I traced it here to the output of this op amp. So this is where the 4-foot strings are summed up. And if I hit a string note, I see the waveform there. And it comes along here and goes to this connector. So when it reaches this connector here, it's fine. This connector goes to the synthesizer switchboard. And I'm going to go underneath here and go to the pin on that this goes to. And it's ground, or floating rather. So there's a broken solder joint here, and I had walked Jeff through this before, and there was a broken solder joint there, and he refloated it and it repaired, but it looked like it didn't hold up. So what I'm going to do is I'm actually going to change the sockets on both of these boards and replace the cable in case there's just some issue there. We'll get this, resolved permanently. So I'm going to do that, and then we'll troubleshoot the remaining issues. So with this disconnected, I can measure continuity between pin 16 on this cable, where it was leaving the lower voicing board, and pin 16 on the board that it's connected to, and I see that there's no continuity there. So this cable assembly probably has a break in it somewhere. With the synthesizer control board out to replace that ribbon cable, now is also a good time to take a look at that intermittent button on the 8-foot synthesizer voice, which is this button here. So this is an earlier ARP Omni 2, you can tell by the black buttons, and the schematic for this board doesn't match the schematic that's published in the service manual. Most ARP Omni 2s use flip-flops to keep the state of which buttons are pressed. And this uses hex inverters, 4069 hex inverters. So the pinout, though, is the same as the connectors to the main board are the same. So I can connect it to this benchtop power supply and fire it up and actually simulate as if it were in the synthesizer and do my troubleshooting with this board disconnected from the keyboard. The problem here turned out to be a bad switch, so I've replaced the switch, and now reliably it turns the light on and off. So I am now good to put this board back onto the synthesizer control board and reassemble everything and test out the fix. So with that ribbon cable and the switch replaced, now we have our violin sound. We have our 4-foot synthesizer sound, and the 8-foot synthesizer reliably toggles on and off when we press the switch. However, we still don't have our 8-foot synthesizer bass, and we don't have our cello bass. So the next step is to look into that. So the next item of business is why the cello voice isn't working. And I followed the cello output all the way from down here on the lower voicing board through the synthesizer control board to the string switchboard. So I'm going to probe the connector pin here, and I'm going to press a cello sound, and you can see on the oscilloscope there's an audio waveform there. So there's a analog switch here, this IC Z1, which is a 4016 analog switch. And the way that that works is there's an input signal and there's an output signal, and there's a control signal. The control signal is digital, so I'll look at the control signal, and that'll tell whether to pass or reject the input signal to the output. So for the cello, the control signal is here on pin 6. So right now I have cello turned on, and that's high. If I turn cello off, it goes low. And I'll turn cello back on again, and it's high. So I'm going to look at the input signal for the cello. So that's pin 8 here. And I have to play a key. So I see that there's an audio signal here when I press a key. And we know the control is high, so this input signal should be passed to the output straight through. So I'm going to probe the output signal here, and I'm pressing a key and I get nothing. So this analog switch is bad and needs to be replaced. So in a real random twist of fate, the exact same problem that causes the 8-foot string bass not to work is what's causing the 8-foot synth bass not to work. So we can take a look at the 4016 IC here that switches that on and off, and the control line is 15 volts, so it's high. So it should pass the signal through. So I'm going to show what happens when I press a bass key. I see an analog waveform, an audio waveform there for the bass. But when I probe the output to that, it's not getting passed through. So I thought it would be something that those two shared in common, rather than just a real freaky coincidence that both ICs for switching those on and off happen to fail. So we'll be changing both of those ICs. Now we're going to look into the issue of the long release time. So this is the schematic for the string control board, and this is the release slider. So on the one side of it, there's a sustain reference, which should be plus 15 volts. On the other side is minus 15 volts. So when you adjust the release slider, you're controlling the value of the sustain bus and putting it somewhere between plus 15 and minus 15. So if we probe the sustain bus, which is pin 3 of this connector P10, it's at minus 15 regardless of what we do with the slider here. If I take a look at the sustain reference, which is sitting on the, which should be plus 15 volts, it is minus 15 volts. So there's two possibilities. One is the sustain reference is, sorry for the glare there, the sustain reference is being passed in from the lower voicing board incorrectly. The other possibility is that this slider is shorted, and it's pulling that plus 15 down to minus 15. So I'm going to turn the power off here, and I'm going to take some resistance measurements on the slider. Really, you can only take measurements for resistance measurements when a component is out of circuit, but this will just give us a quick sanity check to see if it could be shorted. So I have it halfway, so I'm going to measure, this is pin 1, this is pin 2, this is pin 3. So I'm going to measure between pins 1 and 2, and I get about 3K. I'm going to measure between pins 2 and 3. I get about 2.6K. But I'm going to measure between pins 1 and 3, and I'm expecting a large value. When it's out of circuit, if I do this, it's going to give me the full resistance value of the slider. So if it's a 100K slider or 10K slider, it'll give me 10K. If it's a 100K slider, it'll give me 100K. In this case, it's giving me 97 ohms, which seems rather low. So since I need to take this board out anyway to change the an IC for the cello voice, I'm going to pull that slider out and I'm going to test it out of circuit. So I've taken the release slider out and I can measure across pins 1 and 3 out of circuit. And I get 12.3K, and it's a 10K slider, and on these sliders there's a huge tolerance. So 12.3K is within spec. It's reasonable, and it's definitely not anywhere near the 100 ohms that we saw when we measured it in circuit. So I'm going to turn the board over and I'm going to measure between terminals 1 and 3 of this of where this goes in out of circuit. So when I do that, I get 99 ohms. Yeah, 98.6, which is about what we measured when it was in circuit. So it looks like there's something pretty close to shorted across this. And what we can do is this pin 1 connects to the minus 15 rail via a 100 ohm resistor. So if I probe this, there I get our 98.3 ohms. And if I probe this pin 3, I can see that it's 0.05, or sorry, 0.5 ohms. So this is the one that's connected to the sustain reference line, and it seems to be shorted to the minus 15 line. So we need to find that short. So I believe I found the short to the minus 15 rail. The customer had replaced these two tantalum capacitors with aluminum electrolytic capacitors, and their diameter is a bit larger than the tantalum ones that were there. So they are pushing on these resistors that are next to them, and you can see that one of the resistors is pushed into the other one, and one of the resistors is burned up. The burned up resistor is the 100 ohm resistor between pin 3 of the slider and the minus 15 rail, and the other resistor is just off of pin 1 of the slider. So when these two are touching, it effectively shorts the release slider, and it sticks at minus 15 volts. So we're going to replace the burned up resistor, and we're going to replace the two capacitors with a single capacitor that won't cause this space constraint. Here's the two capacitors replaced by one capacitor. So these capacitors are in parallel, and they are two 22 microfarad capacitors. And when you have capacitors in parallel, you can just add the values. So essentially they were acting as one 44 microfarad capacitor. So I took out the two 22 microfarad capacitors that were kind of chubby, and I replaced them with one skinny 47 microfarad capacitor. And I also replaced the burned up 100 ohm resistor, and you can see that there's a lot more room now. The components aren't squished together. I measured the resistance between pins 1 and 3 of the slider back in circuit, and it measured just under 12K. So I was correct to assume that the low resistance between the two pins was a sign of a problem when it was in circuit. So now let's get this back in and test it out. Now that I've corrected that short on the string control board, I've gone back and tested the release of the strings. So with the release turned all the way down, I still have a long release time. So I can probe the sustain bus here on this connector to the lower voicing board, and it should be plus 15 volts with no release, and as I move the slider up all the way, it'll drop down to minus 15 volts. So I have the release slider turned down all the way, and I'm at minus 10 volts. And I can move the slider up, and I see it's dropping down from minus 10 to minus 15 volts as I increase the release all the way. So we have a little improvement in that we're not pinned at minus 15 volts now, but we're not quite there. So there's still some other issues that we need to resolve. To very quickly isolate this problem between the lower voicing board and the string control board, I've disconnected this connector and I've connected the sustain reference to 15 volts and the ground to the ground, and I'm probing the sustain bus. So right now I have a very long release set on the slider, and as I adjust it down to no release, it goes up to 15 volts. So the problem is not with the string control board, the problem is somewhere here on the lower voicing board. And to prove my point, I connected the pin that I was just probing to the sustain bus, and now you can hear the short release time. And I'll move the release slider, and it goes up. So we need to figure out what the problem is there. So I probed the lower voicing board with the oscilloscope, in particular the transistors that create the sustain reference voltage, which is put out on this connector. And I found some unexpected voltages at a couple of the transistors in the sustain override and suppression trigger generator section, this transistor here and this transistor here, which I changed, and that resolved the problem. And of course, here's the pile of parts we removed to repair these issues: the broken cable, the intermittent switch, two bad analog switch integrated circuits, these two oversized capacitors, burned up resistor, and a bad transistor. So now let's go through and test things out. So the violin is working, the viola is working, the cello is working, the bass is working. Over here on the synthesizer section, the 4-foot synth is working, 8-foot synth is working. The button reliably toggles the synthesizer on and off. The 8-foot bass voice and the 16-foot bass voice is working. The release. So previously the release was stuck on, and now I have release set to fast, and it does release quickly. The slider has the intended control over the strings, and all the issues that Jeff was having with his ARP Omni 2 are now repaired. So this is Synthchaser from synthchaser.com, thanking you for watching. If you have any questions, please post in the comments, and please feel free to subscribe for more synthesizer videos. And if you have any vintage synthesizers that need repair, please visit me on my website, synthchaser.com, and get in touch with me. I'd be happy to help you out. Thanks a lot for watching. Bye.